Welcome back everyone. So from the last video you might have got an idea regarding the conduct of a geotechnical investigation program, or it can also be called as a subsurface exploration program. So there are various stages to it. So there is the first stage which requires a desk study, and the second stage involves a site visit. This third stage is about conducting a preliminary ground investigation by means of taking trial pits or borings, and based on that you will submit a preliminary soil report where you will be describing all site details, and you will be presenting the soil results, and based on which you will be giving an initial recommendation for the foundation. And then if the project requires further ground investigation, then we will move on to the next stage, which is the main ground investigation, where other important load test will be conducted on the soil. And then finally you will be presenting your soil report with all correct recommendations and final recommendations. Okay. And as I mentioned, your work as an engineer doesn't really end there. You have to keep monitoring the progress of the work, and you have to check for any possible failures during construction work, as well as after, once the construction is completed, then also you do have to monitor for any possible settlements or failures. Okay, so today we will see, through this video, I'll be giving you a glimpse into how a subsurface exploration program can be conducted. Like, what are the various procedures? So we know the stages involved in a subsurface exploration program, but to know more about the subsurface, that is basically to explore the subsoil profile, you have some test methods and you have some basic Codal recommendations which you have to follow. So we will look into that through this video. So, in order to get the subsoil profile, our first and foremost, go-to method is to take a borehole. So, borehole will give you the stratification, or the subsoil profile with respect to depth. So, there are basic specifications for borehole. That is, you might have to fix based on the project, based on the plan of the structure. You'll have to fix the number of boreholes to be taken at that particular site. Also, you have to decide on the spacing of the boreholes. Then also, most importantly, the depth up to which you have to do your subsurface exploration or boring. Okay, so we'll see how to fix these specifications of borehole. See, the most important when it comes to the exploration of the subsoil profile or subsurface exploration, the most important code for an engineer is IS 1892-1979. So this is the Indian Standard Code of Practice for subsurface investigation for foundations. Okay, so actually this code is intended for multi-story structures, but still we can use it as a reference for many of the projects as well, because this covers most of the recommendations very clearly. So if it is applicable to multi-storage structures, then naturally it will be helpful for us for as a reference for many other projects as well. Okay, so you can actually refer this Bureau of Indian Standards to know more about the Indian codes which are available for various for various areas or streams. Okay. So though IS 1892-1979 will give you an idea about most of the Codal recommendations to be followed for fixing your borehole specifications when it comes to various projects, but still, there are different types of projects involved. So for all those specific requirements to be met, there are different IS codes released. So you have IS 4078-1980, which is a code of practice for indexing and storage of drill cores. Then there is an IS 4453-1980, which is a code of practice for exploration by pits, trenches, drifts, and shafts. So likewise, there are various other IS codes available, which covers the various types of works coming under subsurface exploration, or which requires subsurface exploration. Okay. But most frequently we will be covering or we will be following IS 1892 1979. Okay, you can keep that as a base reference. Then when other complicated projects are involved, like for example IS 6955 1973, this is a code of practice for subsurface exploration for earth and rockfill dams. So for specific works you have to choose, for specific and more complex works, please choose the the respective IS code itself. Okay. So actually I have taken this extract from the code itself. This is from IS 1892-1979, just to show you the scope which is covered in this IS code. Okay, so anyways I'll be sharing with you the hard copy of this IS code, so you can go through it and understand how each of the clauses are mentioned, so you will get a clear idea. Okay, so basically the scope covers to determine the sequence and extent of each soil and rock stratum in the region which is likely to be affected by the proposed work, the nature of each stratum and engineering properties of soil and rock which may affect design and mode of construction of proposed structures and foundations, location of groundwater and possible corrosive effects of soil and water on foundation materials. So basically, um, so basically what you want to determine is the nature of the subsoil profile, and you also need to determine the engineering properties of the soil, because you need to assess the suitability of that particular site soil as a foundation material. And then lastly and most importantly, it is your groundwater table which is going to decide many of the consequences on your structure, so that is very important. Also you have to see whether your soil has any possible corrosive effects on the foundation materials which is used for construction. Okay, because many a times your soil might be contaminated, there might be some foreign materials already in the soil, based on the site you are selecting. Okay, so this code actually covers these three as the main scope of work. Okay, so this is also taken from the code itself. I've just snipped it out. So basically, so as I said, our preference. So what we are trying to find is, how do you fix the borehole specifications? That is, how do you decide on the number of boreholes, the spacing between the boreholes, and obviously the depth of the borehole. Okay. So let's look into that. So the first thing is, as you can see, the clause 2.3.1. So understand that obviously you take boreholes to know the variation of soil with respect to depth. Okay, so you will understand how the soil stratification exists at the site, or soil stratification is nothing but in what layers does the soil exist. It is not necessary that the same type of soil will exist throughout the depth up to the bedrock. Need not be necessary. There can be different types of soils existing in layers, and that is what we call as the soil stratification. So that is what we want to find out. Okay, and then um, so basically the first thing is you have to fix the number and disposition of trial pits and borings. So see, trial pits are what? See, trial pits means it's an open excavation. Okay, it's a pit, and as I said, it doesn't go up to it goes up to a maximum depth of 2 meters. Okay, 3 meters maximum, not more than that. Okay, worst case. So trial pits, it is a manual work itself. It can be done manually. Whereas for borings, you will have different types of instruments, because borings you are doing the vertically you need to evaluate the subsoil profile, and it should technically it should go up to the bedrock, okay, or the hard stratum that exists. So for borings, depending upon the type of soil, you have different types of boring instruments and techniques which are to be followed. Okay, so trial pits are something like open excavation. It's a small pit which goes up to only a minimum depth of 2 meter or 3 meter. And then see, this trial pits actually can even be taken during your site reconnaissance itself, because it doesn't, as I said, it can be the work can be it can be done manually, so it doesn't require any very laborious instruments or anything. So you can take the trial pits during site reconnaissance itself. So you will get an idea about the soil stratification there itself, or the type of soil, at least up to the 2 meter or so. You will be able to understand the type of soil that exists. Okay, so based on that trial pit only, you will be able to assess that initial vertical soil profile, and then you will get an idea. Okay, so this is the type of soil which exists. Obviously it doesn't go up to much higher depth, but it can form a base for your decision making. That is, this will help you to choose a better boring technique for your next level of subsurface exploration. Okay, so once you take a trial pit, you will get an idea uh, about the soil profile which exists underneath. Okay, and then so once you get an idea about the soil, you can recommend a proper boring technique which is suitable for the soil. Okay, so that is how it is done. So as I said, this pit and all can be taken even during site reconnaissance if you can take some workers along with you. So basically, see, the idea is that, mostly borings, if you have a very large site or a small site, number of borings are fixed. Once an engineer comes, experienced engineer comes, he would tell you. But ideally, what we want to understand is, maybe your design engineer, suppose if your design engineer is already ready with the plan of the structure. Okay, so during desk study itself, he had discussed about the plan he is having in his mind. So if his plan is ready, maybe based on that, you will know which are the heavily where which are the load bearing parts of that structure, or basically where are the columns coming, because columns are the load bearing parts of the structure, right? And columns will be resting on your foundation or footing. Okay, so basically wherever the columns are coming, it would be ideal to take one borehole under each column. Okay, and then understand how the vertical subsoil profile goes up to certain depth, because then we can at least assure that we have covered all that loaded areas, because your column is going to be the load bearing part of your structure. So all the loads will be transferred into your subsoil through the columns. So wherever the columns are coming in your structure, it will be ideal to take one borehole beneath each column. Okay, or in the cases of industrial structures, you might be having heavy machine foundations as well, right? There will be heavy machinery involved. So beneath that, so they are also heavily loaded structures within your building. So it will be ideal to take one borehole beneath those heavily loaded machines as well. Okay, when it comes to industrial plants, or when it comes to the construction of industrial plants or structures. Okay, so the idea is that you should that you should be able to understand the soil profile beneath those load bearing parts. Okay, so that is why I said you can take it would be nice if you can take beneath all columns or beneath all those heavily loaded structures which are identified. And otherwise, we'll see how it is fixed. So basically, disposition and spacing of the trial pits and borings should be such as to reveal any major changes in thickness, depth, or properties of the strata over the base area of the structure and its immediate surroundings. So you should be able to get an idea about the soil, not just vertically, but laterally also. Okay, there may be sometimes variation in the soil profile in the horizontal direction as well. Okay, so that is why, based upon the plan of the structure, you will have to fix the borehole to understand the change in the vertical profile as well as change in the horizontal profile. Okay, the number and spacing of boreholes or trial pits will depend upon the extent of the site and the nature of structures coming on it. Okay, so generally, now here comes some recommendations for you. For a compact building site covering an area of about 0.4 hectare, one borehole or trial pit in each corner and one in the center should be adequate. Okay, so this is the basic thing which you can do. So suppose, I'm sorry, this is the compact building they are talking about. So what they are saying is, Okay, suppose if this is the plan, okay, then what you can do is you can take boreholes at each corners, okay, and then you can take a borehole at the center. So this way, see, you should be able to understand this variation as well. Not just this variation, but diagonally also how your soil profile is varying with respect to your plan. Okay, so all these ideas you should be able to collect through boring. So this is one recommendation for a compact building site covering an area of about 0.4 hectare. And then next is for smaller and less important buildings, even one borehole or trial pit in the center. Okay, so for less important buildings, you might just take one borehole to understand the soil profile, and that's it. You will just carry on with your design. Next, for very large areas covering industrial and residential colonies, the geological nature of the terrain will help in deciding the number of boreholes or trial pits. Okay. So, very large areas covering industrial and residential colonies, it depends upon the geological terrain that is existing at the site. So, you have to compare both your plans and the geological terrain existing at the site, and then you have to decide on the boreholes. Okay, and how do you want to space it? How do you want to fix the number and all will depend upon that. It will all be site specific when it comes to industrial projects or residential colonies covering large areas. Okay, and then one other thing is that other method, that cone penetration test may be performed at every 50 meter by dividing the area in a grid pattern and number of boreholes or trial pits decided by examining the variation in the penetration curves. The cone penetration is not possible for sites having gravelly or boulderous strata. In such cases, geophysical methods may be useful. So I had already given you an idea about the various methods of exploration. One of the methods was sounding methods. Now in under sounding methods, you have the standard penetration test and cone penetration test. Cone penetration test itself, there is static cone penetration test and dynamic cone penetration test. Basically, cone penetration test, you will have an instrument like this. Okay, it's basically a long rod at the end of which a cone will be attached. Okay, and there is a sensor attached, sensor provided at the tip. Okay, so what you can do is you can just place this cone instrument at the ground level, and then by means of a drilling equipment you can just, these are extensible rods, you can add on rods to it. Okay, there will be provision for adding more and more rods to this instrument so as to reach to that particular extent of depth. Okay, so you will just keep going into the subsoil profile, and you will get, wherever you stop, you can get the tip resistance, or you call it as a cone resistance. So there is a sensor here, so you are basically penetrating into the soil. So as you penetrate into the soil will give a resistance against that penetration, which will be measured as the tip resistance or cone resistance. Okay, so this doesn't require any boring. You don't have to dig a borehole and then do the test. Here simply you will be using this instrument, okay, which is like a large pencil. So you just keep on drilling it into the into the soil. So you will get the cone resistance values at each point, or at depths wherever you desire you will get, because this will have a data acquisition system. You will know at what are the depths it is covering, so you will be able to get the values wherever you desire. Okay, so what the last law says is that, if you have large areas and you cannot probably take many number of borings, because see, money also matters. These will all take money, so you will have to economically do everything. Okay, so basically what they're saying is you divide the whole site into a grid pattern. Okay, and then what you can do is, I'm sorry, this was supposed to be straight. You can just, this is a grid pattern. Okay, and then what you can do is you can conduct this cone penetration test at all these points. Okay, This is a relatively very simple test to conduct. It doesn't require any borehole. So you just go keep on penetrating into your soil underneath and you will get the tip resistance. So what do you know? So you will get a variation of the tip resistance of the soil with respect to depth for all these points wherever you have conducted the cone penetration test, right? So at each point you will get the variation of the cone resistance, okay, which is a measure of the soil strength which with respect to depth. So you can assess this variation. You can assess it like this horizontally. Assess it with respect to all the points, and then you can decide. Maybe based on this, you are deciding only here and here we need to take a borehole. Then you can take somewhere here. Likewise, so based on the variation of the soil, like for example, when you saw these two the variation of the cone resistance for these adjacent points, and you saw that there is no considerable variation in the resistance values, then you don't have to take a borehole, you don't have to dig a borehole at these 2 points. You can take it at a larger spacing, right? Increase the spacing and take it at some other point where you observe the variation. Like for example, you can take here and you can take here where there might be a variation, you have experienced a variation in the cone resistance values, okay. So likewise only you can fix the spacing between boreholes, okay. So you can conduct cone penetration test by actually dividing your large area into grid pattern, and at each point you can conduct cone penetration test, and based on the variation you have observed, you can decide on the number of boreholes and the spacing between boreholes, okay. So this is how it is done. Now, the another important thing is depth of exploration. Okay. See, normally it is always ideal to take a borehole up to the hard stratum that you observe at site. Okay. So as you go on digging into the soil profile, then what happens is that at some point you should be finding a hard stratum, okay. So it is always ideal to take the borehole up to that hard stratum or up to that bedrock level, so you are assured, okay. And one more thing, once you reach the bedrock, don't be under the assurance that okay, your bedrock is found, now you can stop digging. No, once you find the bedrock, it is important that there is actually another clause uh, that you should dig at least 3 meters into the bedrock, okay. That is ideally you should take the boreholes up to the hard stratum that is existing at that particular site or up to the bedrock. Then once you find the bedrock, do not stop it there, do not stop your boring there, because in some areas or in some cases this bedrock might be, this bedrock that you observed in one borehole, at the end of one borehole, may be just a big boulder, okay, or a big piece of rock that is existing, but it may not be a complete extension of one rock, okay. So in order to ensure that this is not a big rock or a big boulder, and this is a complete rock system that is existing at the bottom, you have to dig further 3 meters, you have to do the boring further 3 meters into that rock, okay. Then if you still finding rock, then it's okay, then you are safe with your borehole, okay. So that is how normally you should be doing, or ideally you should be doing. Or then sometimes what happens is that you might already be having based on the type of foundation, also you can decide on the depth of boring. That is, you can look at it at this way, right? See, if you have already given an initial recommendation of foundation, so you have first you do your boring based on the samples collected, you do your test, you will have your properties of the soil with you, then you give a initial recommendation of soil, initial recommendation of foundation for that particular soil, right? Then what you can do is, so once you have decided on the foundation, there is something called as significant depth, okay. That is, suppose you are planning to keep your foundation. Now this is your footing. Okay, you're planning to keep your footing at 2 meters depth. Okay, after the preliminary, or this is what you have recommended in the preliminary soil report, at 2 meters of depth, if your foundation is going to come, you have to ensure that you have sufficient bearing capacity at the layer where you are keeping your foundation. That is very important. But it is also very important that you also evaluate the soil to some extent beneath this foundation as well. Okay, that is, say your superstructure loads are going to get transferred into this foundation, and your foundation loads are going to get transferred into this soil below the foundation, right? So it is not just the soil at which your foundation is resting which should be having sufficient bearing capacity, but also that, suppose your load is getting transferred like this, okay, and maybe up to another meters. This is 3 meters. Okay, this is 3 meters. Actually, up to the next 3 meters, your loads will be getting transferred. Just imagine, that is the depth up to which the effect of loads will be existing from in the subsoil below the footing. Okay, so then you have to make sure that this point where the loads are finally going to rest is also having sufficient bearing capacity. Okay, so for assessing that only, here depth of exploration will be giving you certain depth recommendations, depth of boring recommendations based on the type of foundation. How it is relevant is what I am explaining. Okay, that is, once you have a footing at a particular depth, you have to ensure, you should know that the load from the footing will be getting transferred into the subsoil below up to a certain limit. Okay, so you need to understand what is that limit, right? So that limit will be specified by your code. For example, say for square footing, they will be saying that, see, this is the width of the footing, right? This is the width of the footing. So what happens? Your code will recommend you that if this is a square footing and if of width b, then your depth of exploration should be 1.5 times b. Okay, 1.5 times b. So that much depth should be considered below the footing, and you have to see that at that particular depth, that is 1.5 times b below the footing, you have sufficient bearing capacity. Okay, so it is important that you assess the bearing capacity at that point as well. So this depth of this code will give you the recommendation of this significant depth up to which your loads are getting transferred below each type of foundation. It will be recommended by this code. Okay, now let's go through this. So depth of exploration required depends on the type of proposed structure, total weight, size, shape and disposition of the loaded area, soil profile and physical properties of the soil. Then normally it should be 1.5 times the width of the footing below foundation. So this is the usual recommendation, that is 1.5 times the width of the proposed foundation level. So if the 2 meters is the proposed foundation level, then 1.5 times B should be the area up to which your effect of load will be existing. Okay, so this depth is also important to you, this 1.5 meter, 1.5 times B. There also it is important to have sufficient bearing capacity. Otherwise what will happen is that, there is a chance that your footing will be just settling down. But then based on the different types of foundation, different type of work, this specification of significant depth or depth of exploration will vary. Then, so you can just go through these clauses. Okay, so as I said, see, based on the type of foundation, they will be giving you what is the depth of exploration. That is, this the engineer should know. This depth of exploration should be assessed, and you have to see that, whichever foundation you choose, and whichever depth you are resting it, that depth plus the depth of the exploration should be having sufficient bearing capacity. Okay, and the settlements also at that depths are within permissible limits. Okay, so please go through this code and understand, you know, uh, how the different clauses have been phrased. So as I said, just a revision, you have to fix the location, the spacing, and the depth of borings. So it generally depends upon the type of structure and obviously the loads coming from your structure. Okay, so this is just a brush up of what we already saw in the code. So as I said, mostly we have to take at the corners. We have to take the boreholes at the corners, and the center of site is also required. You also have to see the diagonal variation of the soil profile. Okay, and then decide on the, I mean, when you take one at the center, two at the corners, obviously you get the diagonal variation. That is the advantage that you have. Then, as I said, mostly you have to take when you have a plan in your hand. If the plan is already available, then it is always better to do a borehole testing. Not a borehole. Yeah, you can dig a borehole at all the beneath all the columns, wherever the columns are coming, as well as wherever heavy machineries or other heavy loads are coming. Okay, then it is always good, it is always ideal to take the boreholes up to the hard strata or wherever the bedrock exists. Okay, then other borings may be taken to at least the significant stress level. This is what I said. See, significant stress level means wherever, if you have already decided on the type of foundation. See, if it's a shallow foundation, you cannot go beyond 4 meters or so. Maybe not even beyond 2 meters or 3 meters. Okay, not more than that. So you already have an idea that you're going to go for this type of shallow foundation. Then you have decided on the depth there itself. So make sure that whichever borings you're taking, it should be covering the significant depth or the depth of exploration based on the type of footing you have in your mind. Okay, you should not just stop it at the depth where you're proposing to construct your foundation. No, you have to go beyond the depth of the beyond that depth where you're proposing to keep your foundation, and you have to explore the significant depth where your loads from the footing will be existing. Okay, so this spacing also we have already seen. For a small building, one borehole or test pit at the center can give necessary data. For a building covering not more than 400 square meter, one borehole or test pit at each corner and one at the center is adequate. So large project, as I said, it's always ideal you divide the whole plot into grid pattern and you conduct cone penetration test at all the points, and then you understand the variation of the cone resistance at each of these points, compare the variation with the adjacent points, and then if you find that there is no considerable variation between adjacent points, then increase the spacing of the between the boreholes. Okay, and then decide on the number of boreholes. So this is the, so go through, I'll share with you the code, go through it and understand the clauses. Okay, so thank you.